Hi everyone, my name is Dan Patipka. I am a professor at Tufts University, and today I'll be talking about some of the work that my colleagues and I at the University of Maryland did titled HackEd, Pedagogical Analysis of Online Vulnerability Discovery Exercises. So when we talk about vulnerability discovery exercises, these are educational tools where students are presented with simple but vulnerable challenge programs, and their goal is to find and exploit the vulnerabilities in those programs. And the benefit of these types of exercises is they expose students to a wide variety of different classes of vulnerabilities and give them exposure that they can then take into their secure development or vulnerability discovery practice in the real world. So why should we think about these from a security education perspective? Well, in fact, these tend to be sort of the recommended practice for security education, or one of the more common practices for security education. In our prior interviews with security professionals, we found that this tended to be the most commonly referenced method for sort of learning vulnerability discovery skills. Also, these types of exercises are recommended by bug bounty platforms such as BugCrowd and HackerOne to people who are interested in joining these markets. So these are, again, these sort of recommended approach for security education. So in this study, we really wanted to understand sort of from a higher level what these types of exercises looked at. Specifically, we asked the question of whether these exercises apply to effective pedagogy taken from the learning science and education literature and how they go about doing that. And then we also asked what challenges do exercise organizers face in sort of establishing the pedagogy for the exercises. We did this through a two-part study. First, we began with a pedagogical review of 31 online security exercises, and then we followed that up with interviews with the organizers of those exercises, specifically 15 organizers. For our pedagogical review, we looked at 5 core pedagogical principles and several different dimensions within each of these. And these are taken from the work by Bransford et al., where they performed a wide review of the education and learning science literature to establish sort of these best practices for pedagogy. And this was later operationalized in the work by Kim and Co., where they performed a pedagogical analysis of online coding tutorials. And so in our review, we adapted that review from Kim and Co., specifically around pedagogy to target security education, so these online exercises. After performing our review, we then emailed our results to all of the exercise organizers, and 15 of the organizers agreed to participate in an interview with us, where during these interviews we reviewed over all of the overall review of the pedagogy of their exercises, and we asked them to identify anything they have missed, any disagreements they might have with the pedagogy that we chose, so you could get a deeper view into sort of their decision-making process and understand what went into sort of thinking about developing these exercises from an educational perspective. So we want to understand the decision process and ask why they did what they did. Now, for the rest of this talk, for brevity, I'm going to focus on some of the most interesting findings, specifically the pedagogical principles where organizers reported challenges and where future work is necessary to better support these organizers. However, before that, I want to make it clear that this is not intended to point fingers at the failings of any of these exercise organizers. In fact, in our sort of review at a high level, we found that many of the organizers implemented many of the pedagogy we were looking at, and that there were some really interesting, very creative implementations of these pedagogy throughout the exercises. So in addition to the directions of future work I'm going to talk about here, we also hope that the much more detailed review in the paper provides a useful roadmap to future organizers by collecting all these ideas in a single place and offering sort of the ability to sort of build off of the experiences of prior organizers. So with that in mind, I'll begin by walking through our results by talking about how exercises organize declarative knowledge. So to achieve mastery in a topic, students have to develop a rich relational framework between concepts. And we specifically looked at 2 ways exercises can guide students in building this type of structure, or this mental structure. First thing we looked at is around just the organization, specifically whether there were any visual or structural cues organizing the challenges. And this goes beyond just the high-level categories that you might see, like cryptography or reverse engineering problems. and down to very specific relationships between the specific concepts taught in each exercise. We also looked at the context within which the challenges were presented. Things like, was there additional lecture material? Was there an overarching project that was being completed? Any kind of narrative or story elements? And whether or not it was presented in a realistic setting. This type of context can help students remember particular things and apply the concepts that they learn to other settings as they try to transfer this learning. So on the organizational side, we found that most of the exercises actually lacked structural cues, so these connections between challenges. And this is especially true when the challenges were crowd generated, so anyone can submit an exercise. This type of model is really beneficial because you can provide a large number of different challenges to students and give them a wide variety of concepts to be exposed to. However, when we talked to the organizers, they pointed out this curating this type of information can be really challenging when it's all being provided by several different individuals. And so coming up with a clear structure is a really difficult task for these organizers. On the side of context, one of the most interesting things we identified here was just that few of the exercises included any kind of realistic challenges. So these are looking at programs where the students asked to sort of work through functions that might not be part of the exploitable code, where they're trying to sort of sift through larger programs or something like that. And this was actually intentional from the organizers. For example, the organizers of the Google CTF said you focus mostly on the problem-solving part, but it gives the players joy. Otherwise, it's mostly luck-based or developing a lot of infrastructure. So here the idea that you want to focus students on this particular concept and help them learn that, and not include a lot of sort of extraneous load. Now, this could potentially be problematic because students might not be able to develop the skills necessary to transfer this to real-world programs where you have large numbers of lines of code. But the trade-off that organizers felt was best here is to focus on these sort of smaller code sets and then not necessarily consider this realism in every case. And so a point here for future work is to understand, well, what's the right amount of realism or sort of realistic challenges? Can you provide only a few and that's sufficient? Do you need any? So future work could potentially consider that. The next thing we looked at was related to sort of practice and feedback. So whenever you're trying to help students develop practical knowledge, it's important to give them the ability to actively practice, sort of get hands-on with the concepts, and then pair that with tailored feedback so that as students are working through and investigating the problem, they don't go down rabbit holes and sort of get stuck. And for this, we looked at two dimensions. First, actionability. Students asked to exploit insecure code, and where they also asked to write secure code to actually go and fix those problems. And then for the feedback side, we asked whether or not feedback was provided in context tailored to the student, or was it given on demand? The student had to go and send an email or contact an organizer via chat. On the actionability side, we found that most of the exercises did not include any kind of secure development practice. And this was because, as the XSS game organizers pointed out, it's really hard to test that the vulnerability is fixed properly. You can include some kind of check or some kind of test case that gets evaluated when they make these fixes, but actually fixing the underlying problem can be really difficult to evaluate. And so instead of actually helping students understand how to write secure code, you're just teaching them to sort of code to the test. And so providing better solutions to help automate this process and help organizers evaluate secure development was something that's would be beneficial to these organizers. On the side of feedback, we found that few exercises provided any kind of correct path markers for any of this sort of in-context tailored guidance. And the reason for this is, again, it's very technically difficult. This has to be tailored to the specific challenge, and each challenge is different. And putting all of that effort in while you're also trying to come up with unique challenges can be very difficult. So instead, most of the organizers provide feedback on demand. Students can ask questions and organizers will respond to those questions. And this is actually something that the organizers prided themselves in, their ability to provide feedback. However, this doesn't necessarily scale extremely well as you have many more students participating. The next thing we looked at was around metacognition. So this is the idea of helping students think about their learning process. And the idea is that you can help students develop a deeper understanding by getting them to reflect on why the solution is correct. If they understand why it's correct, then they can apply it to other situations. Specifically, we looked at questions around transfer learning. So did the exercise teach how, when, and why the concept should be used? And in fact, we found that many of the exercises, or a few of the exercises, explicitly discussed when and why a concept should be used. And this was also, the metacognition was specifically the pedagogical principle that organizers reported not being aware of in most cases. And in many cases, whenever we talked to the organizers, they actually were really excited to implement some of these ideas and concepts into their own exercises going forward. Then the last thing we looked at was around establishing a conducive learning environment. So in addition to the content that's being provided to students, it's also important to think about how that information is being presented and how those concepts are being taught. A negative environment hampers the progress that students might make. If someone is disillusioned or becomes disillusioned or feels pushed away, they're much more likely to sort of abandon the exercise, whereas a positive environment has the opposite effect. It can excite and engage students, and if they get stuck working on a hard concept, they will actually be sort of engaged and pushed to continue working through that and learn more through the exercise. So here we look at, again, two dimensions. First, around peer learning. Was there an active online discussion forum where students could learn along with other students? And then was the terminology used throughout the exercise descriptions, FAQs, places like that, was it supportive of beginners? On the side of peer learning, we actually found that students can generally find a really good community and online forums around these exercises. Even when the organizers didn't themselves provide one, students themselves made them through sort of grassroots efforts. And so there tended to be forums and opportunities for students to learn and collaborate together. On the side of inclusivity, we found that most exercises used really good supportive terminology in most cases. However, there were a few cases where beginners were marginalized. For example, in Hack This Site, the first challenge they provide is referred to as the idiot challenge. And in its description, it says, if you can't solve it, don't go crying to anyone because they'll just make fun of you. And this is problematic not just because of, even though there were a very few number of exercises that had this type of language, if this is the first exercise that a student comes to, they might not only be dissuaded from participating in this exercise, but also from participating in security education more broadly. So as we show through our sort of pedagogical review and interviews, there's several sort of areas where we as a sort of research community need to provide some support to organizers to help them produce better security education around things like metacognition, providing more structure around exercises, providing secure development practice feedback, and tailoring feedback as well. So this requires innovation and improvements of different technology, but also there's some things we can take from the literature and learning sciences. So for example, around metacognition, one thing that exercises might go about doing is probing the student's mental model, forefronting the way that they think about the program and the way the exploit works before the exploit is actually executed. And this helps them, and this has been shown in other domains, to help students think more clearly about what's going on. We also identify trade-offs around things like the difference between realistic challenges and extraneous load, as well as providing a community or sort of managing the community. And around that second point, we think that exercises can improve by sort of incentivizing the production of more educational elements. So in summary, I'd like to thank the NSF for funding this research, along with my collaborators and the exercise organizers who made this possible. I've included my contact information at the top of the slide, and I look forward to taking your questions and hearing from you at the symposium.